Today we'll solve another Leetcode problem of medium difficulty, which is called the decode string. And for this problem, we are given a string value with k, which is given a string, but it's an integer, and an encoded string value. And we are given some parameters. So let's go to a notepad and see how we can solve this problem. Hello everyone. So for this problem, we're given the string value with a digit and string inside square brackets, and we are supposed to find k times the string value. So if it's say a, then we have k times a, which would be, so if k is 2, then we have 2 a's, or if k is 3, we would have a as an outcome. So we can have two kinds of input where we would have something nested. Well, they're both nested, but our initial approach, or the intuitive approach that comes to mind, is doing something, solving it in a recursive fashion. So we solve this, we would have AA, 2 out, and then solve outer brackets, and then so on and so forth. So we have one solution, then move on. Well, we go depth first. AA, 2 times AA, which is AAAA, and then again 2. Or we could have some, which is it's like a single tree, with single branch. We could also have one big root and then multiple branches with 2AA, 2AA, 2AA. And in both these cases, going depth first, going DFS, can help us solve our problem. You can get result of this node, this node, this node, concat all three, and then concat this with, and that would be a result essentially. So we can do it either recursively, or we can do it iteratively using a stack. We would have a stack, and then we can start populating each string. So we would start by pushing in 2. So if you have something like 2A, we would push in 2, then we push in bracket, again 2, push in bracket again, A, and then we wait for the closing bracket. And once we get the closing bracket, we take the top of the stack and wait for the opening bracket. So we pull out A, and then we wait for a digit. So once we get the digit, which is 2, we can get an output, 2 times A, which is 2AA, or well, not 2AA, but rather AA. And we can do it for the whole stack while we have stack that is not empty. So let's see how this would look in the code. Hi, so let's try and solve this. Let's try to code our solution. So we start by initializing a stack. So we have a stack, which is an empty array, and then for each character I in range of length string, we see if we're trying to find if there's a closing bracket. We're trying to find if there's a bracket that we have reached, so that we can start collecting our results for each node. So if you remember, in our stack, in our tree, we start with bottom-up approach. So we start by looking if Si is equal, if it's not equal to the closing bracket, we just simply append it to the stack. See, stack dot append Si. But if it is, then we initialize a substring, because we want to find all the string values in there, and while s stack -1, the top
character in the stack is not equal to the opening bracket, square bracket, we append substring string dot append is equal to stack dot pop. So we're taking the top part of the string and then adding the substring to it. So we're going bottom top down. So B, and so if there was C here. So we keep adding, and then we do a stack dot pop because we want to get rid of the opening bracket, and then we need to find K as well. So we start by K, initializing K as an empty integer or empty string. We'll parse it as integer later, but here, so while we want to make sure that stack is not empty stack, so length of stack is greater than 0, and stack dot -1, and we want to make sure that it's digit. We do K plus K is equal to stack dot pop plus K. So we have K value, K as the integer and substring as the substring we want to multiply. So we have both the elements, and now we simply append it to the stack. So stack dot append integer value of K, and we multiply it by the substring. And as a final result, we just return stack. But remember, stack is not, it's not a string, it's an array. So we want to just join all the values of all the substrings in stack, and let's see if our answer works. Voila, it worked. Okay, and since we're looping through this iteration once, it can be a big O off. The solution can be the solution is big O off, and it's a linear time. Thank you for watching.